right, guys. Today I guess welcome to another session with Bless. And today we'll be showcasing quite a few nifty tricks around how to play around the Linux server. We'll be doing enumeration as usual, and also be getting access escalated privilege on a Linux box. So for those of you familiar with Linux, we'll be doing some abuse of Linux permissions today to escalate privilege. So we'll be looking at the set user ID, the set group ID, and also the sticky bits, seeing how we can probably abuse maybe a file or a binary that is got a set user ID with the roots as roots to escalate that privilege. Guess you're going to enjoy the session with Bless today. Okay, so to start with, I had thought it'd be cool to maybe look within the VPN file. I always connect with this VPN thing, and maybe I thought it would be cool to probably show you guys what is actually in that VPN file. So I'm going to use Nano to open it up. So basically, this is what it looks like. You can see the clients, the dev will give it turn. So it's going to be turned starting from 0 first. But we're using UDP as a protocol. We can see the remote IP. So we can see this is a public IP, not a private IP. So in this public IP, we've got those private IPs, which is where the servers are. Then a few things here I might not be able to explain because of client. I'm going to respect the issue of this VPN access and not drivers. So we can see some certificates happening there. And then we can see more details about the certificates, the encryption algorithm, and all the stuff. Then you can see the signature. So digital signature is going on here with a key, which the issuer accepts. Then we can see the public key encryption happening there as well. Just trying to keep a little bit of secrecy. And that's it. So it's nothing much going on there except for the few details that are set here. So this is where we've got a few details set. So I'm going to get out of this. Enough with that. Then we're going to just run it so we can grab our VPN access. Okay, great. So I think initialization sequence completed. So we should have our VPN access. Let's go check our IP. I'm going to clear the screen. Then I'm going to use this command. I'm grabbing for turn 0. And we got an IP address, which is 10.8180.252. We can see it's /16. So it's a class B private IP. You can see our maximum transmission units, set to 1,500. Then basically that's it. All right, so let's go start by scanning the targets which we'll be working with today. Like I told you, it's a Linux server. So we'll start by doing some footprinting scanning or footprinting recon, sorry. Then maybe after the recon, we will do some enumeration, what we can find. Then maybe after enumeration, we will see vulnerabilities that we can exploit to gain access. As usual, the workflow. So if you've been following my videos, probably you'd have seen me going with this workflow. This workflow are actually what we use as ethical hacker. It's always good to define a flow because it makes the job easy. You know, okay, after this, I'm going to do this. After this, I'm going to do this. And for most penetration tests or maybe security audits, you have to follow workflow. It's systematic, and it also makes it easy for you to explain to the clients what you're doing, because break it in that logic. So first I did some footprinting reconnaissance. I found this, and I went further doing enumeration. Then after enumeration, I tried to maybe look for vulnerabilities, which could be a weakness in configuration, or could be an outdated application running on the secure server, or it could be maybe a policy that is not enforced around users. Over time, over the course of our videos, we've done stops exploiting all these vulnerabilities. Then we gain initial access. Then we can try to do some further enumeration, maybe find out weaknesses that may lead to us maybe escalating privileges or maintaining persistence. Or at some point, I think one of the videos which I had uploaded, I had to pivot from the host to a Docker instance, then trying to gain root shell on the Docker instance, hosting, I think it was hosting Jenkins. Yeah, so you can go on and on and on and on that rabbit hole, as long as it's allowed within your scope. So now we're good. We're going to get right into this. So we've got our IP address. So the target IP address has been given. Let's try to ping it. If we see we can reach it, it's 10.10.199.237. Let's see if we can reach it. Obviously now we can reach it. Great. So which means it's online. And as one of the first things I love to do, my footprint, there's several ways you can do this. If I had a private public IP address, I could use a bunch of other tools. If I maybe go in my up directory and show you guys a few things, I've got this bug bounty methodology that I work with most times. So if I list the content, there's a readme.md, I can cut that just to show you guys. If it was a private IP, I'll be doing public, I'll be doing some web stuff, like using some very cool, powerful tools like recon-ng, httpx is up.sh, just checking that IP, enumerating every domain that is registered to that IP, doing some JSQL stuff, doing some smuggler, do some sniper, spider foot, a bunch of stuff. But all these I can use for public IP anyways, because I can use for private IP because it's within the client's environment, not public facing. So DNS will not allow me to do any of those stuff around that. So that's why we rely on tools like Nmap or maybe any other tool that can use to do private IPs enumeration or private doing stuff like that. So, but maybe on a very good day where I'll be opportune to show you guys what it feels like doing some real time stuff for clients. Maybe if I'm working on a job that is a web application penetration test for a client that is public facing, depending on the client agreement, I might be able to show you guys some videos so you understand what it feels like, not just doing a white box that we've been doing. No, we're doing some some black box tests, being the hacker actually out there. And you tend to find a lot anyways. So we'll quickly jump in and do our Nmap stuff. So we're going to do our Nmap stuff, and maybe starting with our Nmap stuff, let's see what we can see. If we scan with Nmap, I'm going to use a basic scan quickly, but by default, usually you find me using I got that Threader 3000 thing. Maybe we'll try it if it's going to work this time around. Okay, so we've got 10.10. I think our IP address that we're scanning, which is the target, is 10.10.199.273, I believe. Oh, did I make a mistake? Let's start it again. So IP is 10.10.199.273. Invalid format, please use the IP or web address. Okay, I'm not sure why, but I'm going to clear this again and try that again for the last time. Maybe the third time, maybe a charm. I'll do HTTP, then I'll do 10.10 dots. I'm not sure there's a web server hosted there. I don't know why. Anyways, but let's just try that 10.10.1. I think it's 199.2. Oh, I'm doing 273, 237. Maybe that's why. Oh, that's not why. So maybe this thing is crashing. Okay, so let's locate trader 3000 and let's go in. I think it's user local live bean. Let's go look for this, see if I can check find out why it's crashing on me. Copy this. I'll cd, pasting this in my terminal. Then I'm looking for the nano, the trader 3000, the py. Let's do some debugging. It's a bean, Python 3, and okay. So process call, main function, sockets, defaults, print 60. Okay, that's the startup page, the banner. Scanning target IP. So why isn't it taking an IP? Everything looks pretty cool here to me. Identify open ports. Then set timer. Queue. Then do some trading. Port scan completed and print out the results. So try to run an Nmap scan. Everything looks pretty cool here to me. I'm not sure. Okay, exit this. Maybe third time will be a lucky charm. Try 3000. Enter your IP address. So we have 10.10.199. I know there's 237. This is a valid IP address. Okay. So everything is working fine now. Great. All right. So while that is running, I will start an Nmap scan here. So sudo nmap sv sc run the script scan. Then maybe on all the ports. Oh no, just the first 1000 ports. I'm not sure, or just all the ports. Then I'll do a no ping. Just 10.10.199.237. Okay, let me add that A. Although that A already has that C, so I don't know there's that C there. Let me just work with this C password. So the password. So Nmap is scanning as well, and we're doing some scans. We'll just quickly wait for those scans to run while I quickly check off my phone and see what's it got running there on my phone. So trader 3000 is back. Did you see anything? No, not trader scan. Obviously, didn't see anything. Damn you. I'm gonna remove this tool. So I don't want to. I'm gonna remove this tool. This sucks. Never gave me anything good. Whoa. Why? THREADER. Trying to take it out. So how did I install it? No, I think I cloned it. Okay, cool. Anyways, I'm going to check that out later. So let's go to, I think I cloned it. Let's wait for Nmap, or we could go to our browser and try to see if we can browse the IP. First, let me check my host file. I need to remove this, so get my host file. Taking this up, then I'm exiting this. So I could either use the curl utility, take it from the browser. That's 10.199.237. Okay, there seems to be something there. It's just a blank page, I believe. We'll go verify from our browser. 10.199.237. There you go. So it's just a picture, which is what the curl is actually looking at here. Style, HTML body margin, there's nothing happening there. Display block, it's just a block image, an image JP. It's loading image JP. So obviously there's nothing on there. So we can maybe view page source, inspect queue. No, not the inspect queue. I want to view the, what is it? I'm not trying to copy this image. Damn it. Okay, now do that. All right. Anyways, it's good. So we could try some other stuff like directory brute force, maybe go buster, and then you point that to HTTP data queue, then point it to HTTP, then the 10.199.237, then points to word list of I think is user, yeah, it's there buster. Okay, word lists, directory, lists, 2 points, medium. Did I make a mistake? So let's see, go buster, tap help. So there, H, what this? So that should be a W. I used a W, correct? H, it's practically nothing here. So, so should I remove the U? Excuse me. That should be there. Yeah, Damn. Thread, boss, what is go buster? Unknown word. Error, unknown command, HTTP. So it's not recognizing HTTP. Why? Okay. Let me just do some Googling. I'm not sure why that is not recognizing it. My head is not trying to debug. Anything now. So I'm just gonna go to the GitHub repo and look at a few things. Pretty much tired to try to figure out anything on my head. So this gives me more details, you see, than the one I've got on my Parrot box. The usage is not giving me all these details. I know there's a dash U. Okay, so should we try dash U? Maybe remove the directory. I'm sure it's going to throw error at us anyways. Cannot recognize dash U, but I know there's a dash U there, right? Which is the URL. There's a dash W, which is the word list, and we'll find on that. So what's the problem with you, Go Buster? Damn you, Go Buster. There. There you go. Okay, I see you. It's okay. Okay. So let's let it do its thing. I think Nmap is still doing its thing as well, taking a while. But currently, see it's doing study scan. Probably I should have done a basic scan and quickly get out of this Nmap saga. Don't want to waste so much time because we've got a couple of other things to do. So, it's pretty at this point we cannot say anything because Trader 3000 didn't bring me back some smiles. Go Buster is not bringing a smile as well. Nmap is taking its time to do its thing. So, what can we do? But wait, we tried to browse the IP, we didn't find nothing there. So, we can only wait for Nmap because it's going to give us some smile. I guess it's taking a while because I'm scanning all the ports. Probably that's a bad idea. Let me just scan the first 1000 ports. Damn you, Nmap. Okay, scan the first 1000 ports. That might be much faster than scanning all the ports because scanning all the ports is not a productive approach to doing this. So this might be much faster if I check. Already 98%, 99.7, and there you go. Pretty much faster than the first one. Okay, so let's hope we find useful details from this first 1000 ports. So I'm going to go from the top. We can see there's port 21 open. It states it's open. The service run is FTP, that's file transfer protocol. Then the version is ProFTPD 1.3.5. So quickly I could start looking around. Maybe I should stop this Go Buster thing. It's a waste of my space. Clear that out. So I was just waiting for Nmap. So I could start looking around, maybe search exploits, Pro FTPD. FTPD. Let's see what you can find. So we can see obviously it's something that runs on Linux. There are a bunch of exploits, but let's put the version to narrow down my search. 1.3.5, and we only found 3. So there are 3 exploits. There's this, and there will be remotes, Linux remotes at this directory. There's this here as well. So there are 3 of them basically. The first one is command execution, so which means we can execute command remotely. Then the second one is remote command execution. Okay, so command execution, I think you can get a shell. Remote command execution, we can execute command remotely. Then file copy, so we can actually copy files. So we'll be exploiting, I think, most of the 3 of them today for this FTP thing. Then SSH. Open SSH 7.2 P2. You can as well check that. You can see from the banner has been thrown up here. It's an Ubuntu server. It's Ubuntu. So we can use such exploit also to check for that SSH. It's SSH. It's open. SSH. Okay. Spell. If I can spell correctly. Open SSH. We have 7.2p2. So there are a bunch of exploits: username enumeration, user privilege separation, agent protocol arbitrary reliability, user. So it's basically around enumeration. There is none that gives us remote code execution. So maybe we might not touch that today. Then HTTP, we can see it's Apache 2.4.18, another banner showing us Ubuntu server, right? So Apache HTTPD. Let's use such exploit again to find around. I haven't really shown you guys such exploit thing. It works. It comes pre-installed in Kali, but I think for Parrot you have to download it. For Ubuntu you have to download it. I think it's in the app repo, so you can find it there and play with it. So let's search for Apache. Let's search for Apache 2.4.18. Let's see. Maybe a ton of them. Yeah, a bunch of them. Okay, so it's vulnerable to this Tomcat thing, Ghost Storm. I think directory listing. No, that's directory listing only. Open proxy, the PHP, CGI now. CGI cool. This will give you remote code execution. Yeah. So might get remote code execution. Find the code here. Okay, good. So what else do we have? We have RPC bind running. Today we're not doing RPC bind thing, but there's also a fun thing to exploit anyways. Each of these mounts directories. So we've got 139 NetBIOS, some SMB thing, but for Linux version, so we call it Samba. We can play around Samba. We can do some Samba enumeration. It's usually a good way to start up. At least list some shares, look at what is happening there with the shares, configuration, misconfiguration, and maybe find the possible exploits. Then 2049, that's odd. 2049 network file share access control list. So maybe this is for the RPC bind, which is this stuff here. I think it's for this. Is the ACL for the RPC bind. Sees NFS network file share access control list. That's cool. You can already see banners. The host is called Kenobi. So that banner host script ran. So we got some NBT stats stuff telling us some good names. Username, MAC address unknown, accounts. So SMB security mode. Oh, cool stuff. Account uses guests in this test. Authentication level is user. Challenge response supported. Message signing disabled. Wow. So we can do some NTLM relay there using responder to grab hashes if we're in that domain, because we can see message signing is disabled. SMB version 2 security mode. Message signing enabled but not required. Again, we can do responder stuff here, NTLM relay, LLM and R stuff, because it's not required. SMBOS discovery. Well, see, the truth is, let me just be frank with you guys. 70% of what you do when you basically hack is around enumeration, because enumeration gives you the power to progress with your task. I'm already equipped with enough information, and I'm seeing exploit paths just from my enumeration. The possible more than one exploit path from my enumeration. And that's how it works basically. So good enumeration makes the job easy. So thanks to Nmap, it gave us a fully qualified domain name as well. So give us domain name in hex as well. You check this hex flag to interpret what it is. But we can see the NetBIOS computer name as well. You can see the computer name as well. So we've got quite a bunch of information just by enumerating that server. So we're good to go. Maybe we narrow down to look for SMB shares. Let's enumerate SMB shares, since we know ports 139, 443, 445, sorry. is running on the host. So I'm going to clear the screen. Today I'm working with this shell. It's not a root shell, so it's just a normal user. I'm trying to stay away from roots. Not a good practice anyways. So we're going to run Nmap scan, but this time around we'll run specific script scan. So we'll do sudo Nmap. I have to use the sudo because if I have to run maybe script scan for Nmap, I need the sudo to actually do that. So we'll specifically target ports 445, which is where the Samba is. Then we'll run scripts pt. We'll use the script smb enum, somewhat like it, smb enum shares. Then we'll also run smb. There's another script called smb enum users. I can spell. Okay. Then we'll point this to 10.10.199.237. So we're enumerating shares and enumerating users all at the same time. Just trying to see what we can find from doing that. I'm going to copy this. I like to save stuff like this in my script directory, in my ops. Where's my ops? I'm going to cd to ops. Let's see, what do I have in there? I think it's subroots. Subroots. What do I have in subroots? No, it's not subroots. Let me go back. I think it's maybe I see Nmap is done, but I'm just trying to where's that directory? Keyboards, yeah. CD keyboards. Okay, so I'm gonna nano and smb scripts and now the txt and paste in this there. I don't need the IP address, so I'm going to use this. Then I'm going to put this and put IP in there. I'm just saving stuff so I could build a program that will run all the scripts at once. So I'm trying to work on a project where I can put together a little Python program that can do a complete SMB enumeration, or complete HTTP enumeration, or complete maybe FTP enumeration, but relying on Nmap scripting engine. So I've been working on that project for a while, but I hope it'll be ready soon. So you find it on my GitHub repo as well once it's out. Cool. Okay, this is done. Let's go look at what it gave us. So it gave us basically what the first scan did, but more details. So we can see there's SMBA. And from the shared enumeration, we can see there's an account user guest. There's a share IPC dollar. Let's type IPC hidden. Okay, number of users 1. IPC service run cannot be, that's the cannot be user. Maximum user unlimited. It's in the C directory temp. Anonymous access. Whoa, look at that, guys. So what are you seeing? I'm already seeing an exploit path. Anonymously, I have read and write access on the share. Well, I'm just tempted to go do some SMB client stuff right at the moment using that user guest. So as user guest, I've got anonymous read and write access, so I can log in an SMB, then I can upload my payload in there. Then I can go browse from a browser to activate my payload, and I can grab a shell. That's one way you can get in. Like I told you, from a good enumeration, there are possibilities of gaining access to that server. So read and write access, bad configuration, very bad one, like terribly bad one. Okay, second, I've got this anonymous. I think I'm more interested in this one. Anonymous share. Then I've also got read and write access. This one is in the home directory of the user cannot be shared. So this one is in the C directory temp. I'm not sure which user temp. temp. Cool. So temp directory, but that's temporal storage anyways. So I won't go after that. Then on this print share, then I don't have access, anonymous access, so I can't do nothing there anyways. Okay, but cool. At least I've seen a path, two paths, either temp directory or anonymous. Temp is in the IPC dollar, which is default you find on Windows box, Linux box sometimes as well. So we will go after anonymous since we see that I've got read and write, then it's going to take us to the home directory of the user, Kennedy. So I think I'll go after this one when I have read and write access. So what's good? What good can come out of this? Great. So I'm going to clear the screen. Then I'm going to use SMB client. You've seen me use SMB client before. So sometimes it's good to take note of all these scripts because they come handy when you're doing real stuff. It becomes easy for you. I could use this or I could use this. If I'm using this, I'm using 4 because I'm trying to interpret as Windows. But if I'm using this, it's just 2 because I'm using Linux. So it's 10.10.199.237. Then I know it's, if I know how to spell anonymous, so I can just copy it from there. I'm feeling pretty lazy tonight, guys. Permit me. Damn you. My brain is trying to sleep, but I cannot sleep because I have a lot to do. So I'm going to access this anonymous share. Usually to ask me for password, but you know what we do as usual? We just tap enter. So we're trying to log in as an anonymous user without a password. Basically, that's what we're trying to do. So it works. It works if you have anonymous access, like we can see from our. That's why it's good to do the enumeration first before you're trying this. So from my enumeration, I can see I've got read and write anonymous access. So I'll just click enter. She give me the prompts. So I'm kind of in that share. I have read and write access into that share. One quick way to gain a shell, like I showed you the other day, I could create a payload using the MSF console, but I want to stay clear from MSF today. I could create a payload using the MSF console and put it in here. Remember, put it in here. Then we'll go to the browser and browse to this location, list that payload and activate the payload and grab a shell using netcat or even Metasploit's MSF console stuff. But I don't think we're going to do that today. We just want to see what is in the share. Now we're in this share. We can see basically we have. So guys, if it was video, I could do the dir anyways, but that also works here. Cool. So we can see there's a log.txt. Can I type it? That's text. Oh, okay. Help. There's no type command. So what can I use here? Can I use open? Try it. Rewrites there's put commands, but that's to bring in stuff. There's more. Okay. Okay, so I can read it here. Cool. What's better than this? Anyways, sweet. So let me look around this. I don't have to download it to my box. Let me see what's in there. Go to the top, go to the top, go to the top. Okay, so walk with me. What do we have here? Enter the file, which to save the key. Save the key. So it'll be saved in that's SSH. That's a hidden directory ID. RSA. So it's generating a public private key for SSH authentication. So SSH key authentication. The key fingerprint is, so this is Kennedy at Kennedy. Copy that, or better still, I could go check down so you can see the key already. Port 21 standard FTP port, don't use IPv6. It's just like a log that's maybe an admin keeps kind of like UMask is also to it's a good standard UMask to prevent new diaries and files from being grouped and worldwide writable. Okay, so permissions. User Kenobi, group Kenobi. Okay, Sage mode by default, limited site, Sage mode, deny all, anonymous FTP, user FTP, group FTP. This is actually good thing for hacker, bad thing for admin, because I can see all the secrets. Just throwing them at me here. Change this to the work group, telling me all it's doing. Anyways, who cares? As long as you're the hacker. This is what you want to see. Log file, so it's in var log, Samba log. Okay. Authentication. Started on server, remember? Okay. So it's in sync with the Unix password. So if I grab a Unix password, I can actually authenticate to Samba shell. Okay. Good stuff. Thank you for telling me. What else can I ask for? Okay, log on path, log on drive H. Okay, thank you for telling me all your secrets. User ID, group ID between this and this, defaults for WinBend, and okay. Okay, there we go. So we've got a bunch of stuff, huh? What's our business anyways? It's showing us a lot of stuff. We saw the mounts directory /var. So maybe we'll try to go after that mounts directory. We can use an nmap script to actually sorry guys. Can I fetch some water? Seems like a lazy Monday. Okay, I'm not even halfway gone into all I have to do today. All right, so good. What else do we want to ask for? We'll end this. So we okay, get out of there. All right, so what we're going to do now is we're going to run an Nmap scan, check the content of that /dev, or probably put the mount where we can mount. We want to show mounts, see where we can actually mount that share on our own system, because we're going to be doing that somewhere. One way or the other. So sudo nmap. Then we're going to attack that. We saw the RPC bind. If that scan is still there, I think I cleaned it already. If you go to that P was on 111, so receive we can mount, we'll script attack that. We're using the NFS network file share, so the little file share thing. If I can spell script correctly, then wake up blessed. Okay, okay, we're gonna list that stuff. Then we're gonna go after NFS into file share, then maybe stuff. Just run as bunch as many. If you go to the nmap scripting directory, let me show you stuff. I think it's cd user share nmap cd scripts. There's a bunch of them, so maybe we can ls stack al, then we'll pipe this to grep. We'll grep for all the string containing NFS. Oh, damn you. NFS. Okay, so you can see there's nfs.l, nsc, show mounts, stabs. So that's what we're using. We're using all three of them basically. So SCA stats fs show the stats. Then also we're going to use the show mounts. We're running all three of them. Let's see. I think I need to put the NFS show mounts. So run all three of them against the IP 10.10.199.237. Made a mistake. Your port specification are illegal. Oh damn, made a mistake. Look at me. So sorry guys. So it's running. I missed it a week. Fighting with sleep. Okay, so it's come back with some stuff for us. So we can see RPC bind thing happening. We can see the permissions that are set, user ID, group ID, the size, then the file name. So there's backup, there's catch, crash, local, log, the snap, then dub. Great. With all these read, write, execute, very, very funny permissions set here. So I believe you know what these are. Read, write, execute for user, read, write, execute for group, then read, write, execute for other. But for this first part now, we've got read, write, execute user. So by the flag, it's 742. So in total, sorry, it's oh damn, it's 241. That's 7241. So when you see reach, it's 2, right? It's 4, execute is 1. So this first here, according to our Linux file permission, this is 7. The user has got full-fledged privilege, read, write, execute. The group is got read and execute, no write permission. Then others got read and execute as well, no write permission. So if you look at the log, user has got read, write, execute, group read, write, executes, then others. So if we are Kenobi, we have read, write, execute on the logs, as well as dub directory. So going a bit down, we can see there's a /var in the file system. So we're going to try and see if we can mount this on our local system. Then maybe we can read the access. So using the show mount, we see it's in /var asterisk. So what we're trying to do basically, we see if we can mount that, then try to use that to see if we can gain access to the box. It might not be pretty easy to do, but what can we do? We're going to try that and see if it's going to work, right? So great. So first thing first, I'm going to clear the screen. So I'm going to use the netcat to try and see if I can authenticate FTP on that box. Is 10.10.199.237. Then on port 21. Let me see. Okay, so I think I've got that access. Giving me the banners. Then look at that. Okay, great for FTPD. So what we're going to try to do is we're going to try and see if we can execute maybe some basic command. See what that's going to give us. Probably to see if we can grab the content of the SSH and see if we can use that to authenticate using SSH. So what we're going to do is we're going to do a sites. Just work with me the command. Oh, I'm not typing in yet. Sorry. SITE CPFR. Then we're going to go to home. Then we're going to go to Kenobi. Then we're going to go to .ssh. From what we saw, then we'll go to ID _RSA. Let's put an enter in there. So ready for destination name. So find the 305 file for directory exists. Ready for destination name. So where we're going to send this to, let's say we send this to sites. Copy to var. Then we put it on temp. Put it on temp. then we'll call it ID underscore RSA. So what I'm doing is I'm remotely grabbing that file from the server and I'm dumping it on var, because I saw that from my enumeration here, there's /var, and I can actually access the /var. So I'm grabbing the ID RSA SSH keys and dumping it on var. So let me see if I can copy to that. So that copy worked out successfully. So we're good to go, which means we have that SSH keys to authenticate in var temp as a file called RDRSA. So I'm going to kill this. I'm done with that. I'm out of there. So what I'm going to do is I'm going to go to my local box and I'll try and see if I can mount the var, since I can see from my Nmap Scan here that I'm able to mount the var. So let me try to see if I can mount the var, if it's going to give me a smile. So I'm going to clear the screen. I'm sleep talking. I think I'm awake and I'm asleep. Sorry guys. So I'm going to clear the screen. So what I'm going to do is I'm going to make that MNT mounts. Then I'll call this Kenobi NFS. Okay. Oh, there's no sudo. What is the secret? Sudo. Boom. There you go. Okay, so I'm gonna mount that var directory on my machine. So it's 10.10.199.237, I believe. So we're gonna mount that on var. Then we're mounting this on MNT. Then we put in this Kenobi NFS. I hope this works. If it doesn't, then try again. Okay. Fail to apply. I didn't put the sudo command. Is it a permission thing? Sudo. Okay, so that's working out. It worked. Okay, great. So sudo ls stack la. Let's list the content of MNT. Then it's Kenobi NFS. What? Did I make a mistake? Is it capital K or small k? Small k. Okay, so small k. Oh, damn you. Okay, so we can look around and see what we can find. We mounted, what is it? I can see var here. Damn. Run snap dub. Okay, I cannot see, but I can see run lock. I don't know. I can see run lock. I can see crash. I can see mail. I can see. Okay, so let's hope all things being equal. Now that we're there, what we're going to do is since we have a network mount on our machine, what we're going to try and do is we're going to try and go check the var.temp and see what is in there. You can see that temp thing happening there. Let's go see what's happening there and log into the account. So what we're going to do is we're going to copy, just execute a few more commands. We're going to copy. Let's see if we can copy the MNT and Kenobi NFS, then temp, then the ID RSA. If we can drop it in here, where are we actually? We are in we're in Cyberstrix Parrots homes. So we can put it here. That didn't give us a smile anyways, so something is wrong. Missing destination file. Oh, okay, damn. Put it here. Okay. Okay, I think it worked. Let's list that. Let's see if we can see that. I have to see how we. Oh, there it is, IDRSA. So let's cut the content of IDRSA. Yeah, that gives me some life. So that's the SSH keys. So we just remotely grab the SSH keys from that remote server to our server. So what we're going to do now is we're going to use these keys to connect SSH. But before we do this, usually IDRSA files logs the permission 600. 600 means user has got read and write, no execute, and every other person has no access. Group no, others no. So we're going to change to clear this. We're going to do some, there's a bunch of crappy stuff in my, what the hell? Don't working directory. I need to clean up and messed up stuff in there. So what we're going to do is we're going to chmod sudo chmod. We're going to change this to 600. So I have read, write, and not execute. Then every other person does not have access both group. We'll change that for the IDRSA file. So it looks pretty good now. So we're going to try to do is we're going to try and connect SSH. So we're using .i because we're using an IDRSA file, .i. Then we'll connect to the user Kenobi on the box 10.10.199.237. Oh, just what I need right now. SHH. Blessed. Are you still sleeping? Okay, yes. Okay, I think we got that access. What? IDRS permission denied. What the? No. What? Permanently added to list of known hosts. Load key. Permission denied. What? We grabbed the key already, so why is it telling me permission denied of all the things I want to see now? Is it that? Let me run that command again, maybe I should do. Yeah, so I wasn't able to read it. Since we did it as sudo, I think we had to execute it as sudo for us to be able to read that file. So it wasn't using cybersecurity. Using cybersecurity being a member of the sudo file. Got you. Okay. Hacking is fun, you know? Like I always say. So where's this? Is a Linux box. There's a user flag, so we can cut that in to go show them that we got in your box. Damn you. And where are we? We're in the home directory of Kenobi. So great. Now at this point, we're going to talk a bit about file permissions. I'm going to share a few details with you guys just so you know what I'm talking about here. So a quick way to show this, let me do it ls-al. So I hope there's anything with a special bit set. There's nothing here. So that's bad. But if you look at what you can see in Linux, these are the permission flags. So you see all those dirty DRWX gibberish, whatever you want to call it, gibberish stuff. Great. So what they represent file permissions, just like you have in Windows. You can set file permissions, you can set directory permissions, you can set group permissions and all the stuff. The same thing you have applied here in Linux. You can manage this using the pluggable authentication mode in Linux PAM. But basically what we're looking around here is just a basic, nothing really pretty dope, just some letters representing permissions. So the R stands for the read, the W stands for the write, the X stands for execute. So in some cases, you will see RWS, not X, RWS, or maybe RWT. So where the S is now, the S, if it's in the first three letters, like RW, normally we saw RWX. If you see RWS, not RWX, it means the user has a set ID, the set user ID. S stands for the set user ID. So the suite, or call it sometimes the suite. The suite bit basically is saying the user executes the file with permissions of the file owner. So which means, take for instance, there is a file here, user.text. Then maybe see there is a RWS, the first three updates. It means the user can execute the user.text file with the permission of the file owner, even if the file owner is root. This is what we're going to be abusing. We'll look up for some files or executable that is owned by root, but there is a set user ID bit, so which means we can execute the file as root. So we can abuse that to get an elevated privilege, which will be the owner of the file's privilege, which is root privilege. So that's for the first S if it's in the user space. Then if it's in the group space, it's called the SGID, or just the first one sounds pretty sweet, SUID, sweet, like sweet. The second one sounds awkward. It's SGID. So SGID is the set group ID bits. So the set group ID bits, what it does basically, it means the user executes the file with the permissions of the group owner. So if the group owner is root, you can execute that file as root. Mind you, the user is not a root, it's not even in the sudo file, but because there is a set group ID bit set on the file, the user can execute the file as root. Now, for us hackers, we can abuse that misconfiguration to gain root access just by a file that has been misconfigured. Then the last one I'm going to talk about is called the sticky bits. So the sticky bit has no effect on files, but rather on directories. So what does it mean? It means if a sticky bit is set, the user cannot delete the file, from other users. So which means the user does not have the right to delete the file, thus the name sticky. The sticky bits is clear on directory, not on the file, but the set user ID is clear on file, not on directory, while the set group ID is clear both on file and on directory. Now for directory, the set group ID, what it does is that the file created in the directory gets the same group owner, so which means if it's root directory, root owners, kind of like what it's explaining. So what we're doing today is, with this initial access, we could probably sell it in the dark web and make some money, but we're not doing that. Just kidding. Don't mind me. Okay, great. So what we're going to do is we're going to grab this initial access, then we'll enumerate the box to find out for misconfigurations and the file permissions. Remember, so we're abusing misconfigured file permissions to elevate our privilege. So what we're going to do is we're going to use the find command to find misconfiguration. So I've used this before. I'm going to put find, then I'm finding what permissions that were specific for user. So with the switch, user equals with a switch, then the type we're basically looking, then we're going to pipe that to dev null. So for any error, we don't want to see that thrown up on our screen. We just pipe that out into that black hole. We don't want to see any trash stuff. Okay, great. So we're going to run this. We're looking for files. Already we can see there's the SBin mount and a bunch of them. Cool stuff. So let's go analyze them. You see there's the SBin mount NFS. You can see there's user lab. All this we could analyze. I could run this command on my local box. just so I'm able to do a comparison and see which of these is not supposed to be here, that is there, that I can actually abuse. Maybe it was set manually. So I'm going to run that same command. I'll copy this command. If my mouse will behave, my mouse is misbehaving. If I didn't type that, if I didn't pass that to dev null, trust me, you see a bunch of useless things that we don't even need happening on the screen. So I'm going to run this on my own box. Let me do a comparison of the two results. A good way to analyze and look for what I'm looking for. So let me see. So we can see eject, open SSH key sign, bin, change function, pkexec, password. Okay, I could also be trying this locally. So I could be trying all this locally since I have a Linux box also here. Let me see. User bin pkexec. That one is there. Ooh. How about I know there's password. I know there's new UI. Is that there? UID map. I don't know if that's okay. Menu. You have menu. Menu is like menu. No such file and directory. I know there's sudo. Of course. I know there's chsh. I know there's ads. Oh, it's to my box. Oh, this is not Kali. This is not the print. This is parrots. But still, I should have those bunch of stuff in there. New group, new mount, F user mount. I know that one. Ping, so ping 6. I know that's architecture. Eject. Daemon. I haven't seen menu before. I don't know. So I'm a little bit touched to play with that menu because I haven't seen that before. Kind of like this command is not running on my box. I don't know why. Maybe there's a bunch of garbage. Let me cancel this. Maybe try it again without that part of it. It's still not running. Cancel this. It's still gonna take a while. So great. So what we're gonna do is we're gonna try to see if we can maybe find a way to abuse the menu, since we see it also got the sets from our command. We're looking for files with permission, for files which that's the type is file F, which the sets UID bits, sets UID bits. So that we're looking for. So we found this bunch of them. We could try all of them out. I think I'm going to work with menu. I don't know. I just haven't seen that. It's strange. I haven't seen that around. Because I know I've seen a bunch of all the others, but I haven't seen menu in bin, user bin as crazy. I could just go to my user bin here, list the contents. There's a bunch of stuff, but I don't think I've seen anything like menu before. I'm going to scroll all the way to the top. There's a bunch of stuff. So there's AA, all the executable stuff. But menu, that's pretty standout for me. Go to IJKM, ME, MI. Reducer, ME. There's nothing like that. So that's really strange. So that has been configured by the user or by the admin of the box. So which means we're going to abuse that misconfiguration in that menu file. You can check on your own Linux box if you find anything like that in your bin, but there's obviously nothing for me. So which means that tells me something is wrong somewhere. So what I'm going to do is see how we can abuse that to maybe escalate our privilege. Probably. So, but before that, I'm just going to play. Can I use clear? I'll play around the box. Let me see. I have config. It's our IP address. Just playing around. Maybe dump the content of etc passwords. Maybe do that for shadow. Can we? Obviously not, I know. Okay, so we're not user yet, so who am I? Obviously we're not root yet. Great. So sweet stuff. We're just fooling around, guys, don't mind us. Let's fool around bits. Okay. Damn you, where are the options? Okay, so good. So let's play around. Still playing around. There's no harm playing anyways. So no, we can't cause any harm. We can see 200, okay, so which means we hit it. So there's an Apache server running. Okay, good. E-tag, content length, byte range. Okay, we're just playing around, guys. Uname is a Linux box, so uname 4.8.058 generic. Lots of stuff. So we're just playing around, looking at what we can find from the box. Maybe list the content of this directory. Maybe try to where we pwd. Maybe try to go back. Maybe list the content of form. Maybe try to go back. Maybe try to cd etc. Can download some stuff and put it here. Maybe run something like linpeas. I've shown you how to do that before, so I won't do it. Run linpeas, look for other privilege escalation, or look for Linux kernel. I haven't shown you that. Maybe that's the next thing I will do. Kernel exploits. We'll run something like dirty cow to run for kernel exploit, that we can actually exploit to escalate privilege. I'm not going to do that today, but I will make another video for that, show you guys some Linux kernel exploits to escalate privilege and gain persistence. So good. Now that we've done this much, and we know there is a menu which we want to actually exploit. So how about we do some commands? Echo. So first we're going to echo bin environment sh to curl, since we know we have curl. So so cd home cannot be. Okay, we need to stay in our space. Okay, great. So we're going to echo, or maybe we'll go to the temp. Can we go to temp? We can go to temp. Good. So that's the thing we saw via the call. So what we can do is we can maybe try to see if we can echo. I will look for GTFO bin, maybe for anything in that EF GHIJK man mounts. There's nothing there. Damn. Okay. Let's get an echo. Then sh. We can pass that to core. Oh, so it works here. So let's see what we have. So there's core there. Great. So how about we chmod that call to to give it full rights. Oh, then ch mode. Give it full rights. So it's now executable. So about to execute it, but before we do that, we export path equals, put this in temp, then we'll put this in the variable path. See, okay, so that seems all good. I'm about to execute the bin. Sorry, bash. Sorry, user bin menu. Okay, status check kernel version like config. So status check. I'll go for 1. So it executes. So in the menu, we have, I think they may have created that executable to check for status, to check for kernel version, to check ifconfig. So, and they give that executable root privilege. So it executes as root. So what we've just done is we set the path variable and we try to abuse the permission on that executable called menu. So now we select 1 to check status and it gave us a root shell. Who am I? We're roots. Can we cut the content of etc? It's not stable. You can do the Python 52i thing to get a stable root shell, but there's no time for that. Shadow, so we can cut the content. So obviously now we are roots. We can see all the passwords. You can grab them and go crack them remotely to own the box completely. So we already own the box. So quick caveats. If you look at what had happened, we had actually abused file permissions, misconfigured file permissions. Basically, we've abused misconfigured file permissions to execute a file that has root permission as a user, then gaining root shell because we made some modifications, just some minor modifications. So we can see our effective ID. The user ID is roots, group ID is Kenobi, the groups is Kenobi. So our effective user ID actually will run as roots. So which means in this shell we are roots, although we are actually Kenobi in Kenobi group, but we're running in the shell as roots. So that's the whole essence of abusing misconfigured file permissions. Now, there's a whole lot more that can be done from this point, but for the purpose of this lesson, we're going to stop here. A quick caveat: it's always good to, as admin, to check the file permissions that you have set on executables, mostly at Python and all these executables. Check the file permissions, because if you have not done a good job, if I run that find command again, if you've not done a good job, maybe you've done a bad job setting bad permissions, someone can just run something like this and find. I could abuse any of this actually. If I go to GTFO bin, I could look for any of these, maybe sudo. If I go to GTFO bin, I could go check for sudo, maybe find the GTFO bin that I can use to abuse IGQL, MNOPQRS, sudo su sudo. I could check the GTFO bin. Okay, there's no abuse here, so it's just sudo su. So which means I don't have a suite thing going on here. So let me look for umounts, anything on umounts. It's a good thing to play with GTFO bins because you get to find how to abuse permissions, mostly sets. There's su, there's fuser mounts, there's I could find most of this here actually. Then if there's a switch, if I'd found maybe tar, I could, or maybe tar sets or something, I could check the switch and I could see a bunch of ways I can actually elevate privilege by running all these commands. Just copy and execute on the host and you grab a root shell. Basically, I think I've shown you that. I think I'd shown you the one for Python, and we'd used was one of these. This one was to grab the stable shell. I can still execute this here if I want to. I can execute it on this box. Maybe just to grab a stable shell. Maybe I'll do. Oh, I can go back. Yes. Bash. So maybe I'll do bin bash. Close this, then close this. Great. So you see what happened. Kind of like I went from this unstable shell to a stable shell. So now I can type and I can clean without giving me that rubbish stuff. I can autocomplete. I can use autocomplete. See, now I have a stable shell. That's the goodness of GTFOB actually. It's a cool stuff to play with, guys. Check it out. So I'm going to close this video here. It's been a long one, I know, but I decided not to go too fast so I can explain some of these things in details and you can see how stuff work. But I urge you to practice, play with these stuffs like GTFOB in your Linux box. Try to run the find command to look for misconfigured. I think the find command is somewhere there. Try to run the find command, look for misconfigure. I think it's there. Let me see if it's in my. No, that's the bin bash thing happening there. I'm not sure. I think I can grab it from here. Yeah, there you go. So try to run commands like this in your local box. Look for misconfigured. You can change this to G. So you check for group. This is you, it's checking for users. You can change it to G, check for groups. Look for misconfigured permissions. Try to correct them, mostly for those binaries, because they are one quick way someone can exploit a misconfigured permission to escalate privilege on your box, and it's game over already once the person is able to do that. He has root permissions. He can now go ahead as covering tracks or go ahead as maintaining persistence, the point where it's going down to the kernel level. It becomes difficult to even detect whatever the person is doing on your box. So we're going to close this video here today. Once again, thanks for your time. It's been an awesome experience again. I look forward to seeing you next time. I think I will be doing some Linux kernel exploits, so we can look at how to use some cool kernel exploit module to exploit Linux kernel. We've done pretty much around Windows, so we'll be doing some Linux stuffs from this point on. Thanks for your time and have a good day.